All right, I think I'll go ahead and get started. Welcome. This talk is the test SDK, and SDET's best friend in monolith-to-microservice migrations. But this is not necessarily about just distributed architecture. It's just a general talk just to advocate why it's beneficial to have a testing software development kit in general. Doesn't matter if you have a mono repo set up, distributed architecture set up, somewhere in between. Maybe you're in a greenfield state right now with your project. In any case, I'm going to try to advocate for why you should build one of these. All right, so who am I? So a little bit about myself. My name is Wayne. I'm currently a principal SDET at uShip. I'm actually from Austin, Texas, so I actually flew out here. I really enjoy Portland. This is my third time here, so it's nice. It's actually not as much rain as I would have expected. But yeah, I've been at uShip a little bit over 6 years now. And just over those 6 years, I've worn a lot of different hats. So I'm our test architect. I'm also our QA lead. I've been on basically every team in our organization at some point or another. And I've done a lot of work. Most of my work has primarily been moving uShip to CI/CD. And so a lot of that just been, as the SDET IC, just work hopping on different teams, hopping out, hopping on a different team, hopping back in. And just try to help process across the organization. And so this actually marks year 11 of me being in the quality engineering space. I still love what I do. PNSQC is actually special to me because PNSQC was the first conference I went to in 2019 or so. And that's when I learned actually a ton of stuff, like just across the board from like security testing, chaos testing, all that. I brought it back to uShip and we actually implemented a ton of that stuff for our organization. And so coming full circle, I got a chance to write my first technical paper and come here to present. So I'm really excited to be here. Hopefully you find this talk useful. And there's some of my contact info on the screen if any of y'all want to connect afterwards, or if you have any questions you want to talk about. And so this is our roadmap for today. This is just it's going to start pretty high level, but we'll show a little bit of code. We'll talk a little bit more specifics. But we'll set the stage first of why did this test SDK have to be built in the first place? And I'm going to say test SDK a lot during this presentation, but if you're not familiar with the acronym, it's software development kit. So we're going to talk about why we had to first build this software development kit, like as I led the QA efforts at uShip, especially as we migrated from this monolithic architecture into a distributed system. And then we'll talk a little bit about the tangible benefits that we saw from having this test SDK and what kind of problems it solved. And then after that, I'll give you some pointers on, here's how you get started building one. And then I'll finish up with, here's some of the pain points that we experienced after building it. Because everything's not flowers, not everything's roses. And so here's where we'll go. So let me just talk a little bit about uShip, just to set some context. So uShip is a leading shipping marketplace for effectively big and bulky items. The way I explain it to most of my friends is, think of it like eBay for shipping. You have a marketplace, you go there, you put up some kind of posting on a job board. There's a shipper who is basically you, the customer, who wants to ship something. There is the listing itself, which is the item or items you want to get shipped. And then there's a carrier. The carrier is the person who basically takes your item and ships it to point B. And so these are the three core objects that interact through our system. And some of the code that I'll show and some of the examples I'll talk about primarily reference these. But for all purposes, the shipper and the carrier are basically the users in our system, and then the listing is the primary commodity that gets interacted with. And so uShip this year celebrated its 20th anniversary, and so it's been actually quite the journey as a company. But what's on the right side is basically our monolith architecture, and for all purposes, it doesn't really matter for this talk, other than the fact that you can see there's a lot of lines. I don't know how well you can see that from back there, but there's a lot of lines, and it's really crazy, and it's really big. And so the history about how the architecture of our company came to be is actually very entertaining in and of itself. We onboard people like a 1-hour presentation on how the heck did we actually get here. And it's actually really amusing because the people who built our website were not software developers. It was someone who self-taught themselves something with VB and somehow built something that actually was profitable, and we somehow have this company that works. Yeah, it's amazing. But yeah, this ginormous spaghetti code of whatever you want to call this. It's gotten to the point where in the last 5 years, even though every developer and QA and SDET is given basically a max spec PC on the onboard, we can barely build the application at this point. So it's really hard to make any kind of changes. It's really hard to do local development, much less pushing things up through a pipeline. And so when I first joined 6 years ago, that's when our architecture group was starting to figure out, okay, how do we decompose this monolith? How can we get into distributed systems so that it's a lot less painful to make changes, develop things, build new features? And so the flip side, so that's all the development side. The testing side is also equally as nasty. So we had 4 different API test frameworks and 3 different Selenium end-to-end test projects. And they all tested the exact same functionality. So it's basically like a scaled rollout. So like, oh, we wanted to use this different test runner. So we built this different test project, but we never deprecated the old project. Now we have to maintain 3 projects, or in this case, 7 projects. And so it's really challenging to maintain more than one test framework, much less 7. And because our pipeline still had to run through all these tests, basically we had 4-hour deployments if we were lucky in our CI/CD, because 4 hours is like, hey, everything went green on the first try, which maybe that happens, maybe probably not. And so it takes forever to basically get releases out. And then I think what I really want to point out about this monolithic project, though, is because we have these 7 different test frameworks, they all implemented their own test helpers. So going back to the idea of the shipper, that shipper is created 7 different ways. They all look similar. They all generate a shipper user, but each project has its own shipper creation method. So keep that in mind as we kind of move forward. So distributed systems. Okay, so this is our new architecture. And everything that giant ball of mud was is represented by that monolith little picture on the right. And at first it's like, oh, okay, it still looks kind of crazy, maybe less crazy, but it's still crazy. But I think the actual developer experience has been awesome. Because deploys only take 10 minutes. So we have used microservice architecture and micro front-end architecture. So new UIs, it's all separated from the monolith. Our APIs are also separated. And so everything has its own pipeline. Each of them has their own isolated tests, so it doesn't have to go through the 4-hour deployments. Everything's great in that sense. No one needs to load Visual Studio to try to build that monster application. You can just spin up a small stack on your own. Our new stack is also in Node.js. Maybe some of you are diehard C# fans. I am not one of them. So I get to use Node, which is my preferred language. And so everyone wins. And I think even for the QAs in our org, they would say the manual testing is not even that bad, because now you don't have to build that ginormous application. You can just build in a separate ephemeral environment, just like the single page application that's now in the micro front end instead. And so I've talked a little bit about the manual testing, talked about the dev experience. What about the test automation? And I think that is where we started to run into problems. So, it's great that we have this test first mindset. Teams have added testing to all their microservices, all their micro front ends, and from an organizational perspective, we didn't have a lot of architectural oversight at the time. So teams kind of just went every direction that they wanted. And so we had many different frameworks, and basically engineering was tasked to support all of them because there was no governance. And so if you swap teams, you basically swap to a different company because the tech stack is like, this is not familiar at all compared to my current team. And so just as an example, just from purely UI frameworks on our micro front ends, we had some teams using Nightwatch, Test Cafe, Playwright, Puppeteer, or some teams just didn't use anything at all for some reason. And so you can kind of imagine if you were an engineer and another team asked you for help, like, hey, I need some help figuring out test automation. Well, your test automation is in Test Cafe. I don't know how to use Test Cafe. So let me go look it up, how this API works, and let me come back to you. And so there's not a lot of cross-pollination. There's a lot of pain. I think going back to that idea also, we had 7 test frameworks already for the monolith. Well, this kind of perpetuated itself also in our distributed system architecture, because we just started seeing wet code everywhere. For those of you all not familiar with the acronym WET, it's basically write everything twice, or in this case, write everything 20 times. Every test in our system needs, at the minimum, a shipper and a listing, probably a carrier as well. And so that same test helper is written multiple different ways, multiple different libraries. So for example, one of our repositories might use Axios for their HTTP client. One might use Node Fetch, one might use Superagent. They're all trying to implement the same API. And maybe if you're on the same team, you just copy paste that around all your different repositories. And so you can imagine everything is everywhere. It all looks similar from a top level, but underneath the hood, that's all implemented differently. And so the one fateful day happened where we actually had a major change to our API. And so basically, this one team basically had to add a new required parameter to our user creation endpoint. And then they pushed it into the pipeline. And not just the one pipeline blew up, every pipeline in our company blew up. And so this team had to make 20 more PRs to go fix every single one of those pipelines because they had to go fix all the user creation helpers everywhere. And so I think this is the point where our SDET group really took a step back and we were like, okay, there has to be a better way than to open up 20 PRs every time someone needs to make a breaking change. And so, and also this is not sustainable in a distributed architecture. We need to have some governance. And so after some conversation, we decided to create a test software development kit to help facilitate test automation throughout the rest of our system. And so thus begins our first point. So what is this mythical test SDK? And honestly, it's actually fairly simple in the sense that software development kits in general, they're just a collection of tools and libraries to facilitate software development. And more specifically in this case, testing. I like to think of it as either like a toolbox, a multi-purpose toolbox, or maybe like a Swiss Army knife that probably has most of the things that you need to get work done. I think oftentimes you'll see like API wrappers to maybe call endpoints for test data creation. Maybe there's some configurations for environments, grabbing secrets, authorization, et cetera. But it really is no one size fits all. You can put whatever you want into your test SDK, whatever is useful for your company. And so, but I think I do want to point out though, like the main purpose of having a test SDK is to basically enable a dry test architecture. And if you're not familiar with the acronym, dry is don't repeat yourself. And this is basically the antithesis of the wet code. And so how does this test SDK enable dry architecture? And so benefit one, and if I take nothing else away from this presentation, this is why you care about a test SDK in a distributed system specifically. It basically centralizes your core test methods. So my personal belief is in an ideal world, end-to-end tests specifically should be able to generate their own test data so that you're able to maximize your test isolation so that state from one test doesn't transfer to the next. Maximize parallelization so you can run as many tests as you can, as fast as you can, and then test speed. And so I think there is a time and place for canned data, or like prefabricated data. But generally at our company, we just prefer to generate test data on the fly and then run our tests. And so, like I mentioned before, every test basically needs a shipper and a listing at the minimum. And overall, that shipper and listing for the most part looks plus or minus the exact same. So maybe there's like some commodity differences and whatnot, but the shape of the objects are the same basically no matter what. And so I think we've already kind of made the point, like at the time we had 20 like micro front ends, microservices. We've obviously expanded to a lot more, but nobody wants to make PRs for that many things whenever something changes. And so, but with having a test SDK, you basically have all your test data creation in one maintainable location, regardless of who the consumer is. So all your repositories can just download this test SDK, implement its methods, and then they don't have to worry about, you don't only have to worry about changing it in one place when you make changes. And so I really can't stress this enough that this is the reason why you should have the a test SDK in a distributed system, because it just makes maintenance that much more easier. I think I'm gonna talk about some other benefits after this, but basically every benefit is basically a pretty distant second. For those of y'all who are like familiar with like design patterns, effectively, this is a portable factory. That's all it really is. And so this slide is basically just some very high-level sample code. It's nothing that special. This is just our user creation methods. But basically on the left, there's just a very generic user creation function. It takes in some custom parameters that basically calls the function that's on the right to basically create a user. There's some base models, so I don't think you can see from back there, but there's a base user and some user overrides that you can put in such that you can change up your test data if you need to. But yeah, it basically just passes all that information, generates a user, spits it back to you, and your test can use that user for whatever it needs. And so it's nothing particularly special. It's just the same. It's actually the same helper that existed in our test automation suite prior to creating our test SDK. It just got transferred to a central location. And then, yeah, in terms of consumption, like for those of y'all who are in the node space, this is just your package.json, and you just install as a dev dependency and install it via npm, and you're good to go. I want to highlight benefit 1B real quick, because this presentation is mostly about test automation, but there is actually a use case also for the manual QA side of having a test SDK. And so we already have all the wrappers set up, API wrappers set up. And so it's actually really easy to just write setup data test scripts for manual testing as well. So you can just write a very simple script, save it maybe in your repository somewhere, and then you just basically just cherry pick whatever setup you need and then print out the relevant data. And so as an example, for us, so we have different types of listings. One specific type of listing that we have is called quote unquote auto booking, because you can basically, once you create the listing, because of like partnerships that we have with different integrators, it can automatically get basically paid for and checked out and put into a book state. But it's actually really time consuming to basically set that all up from scratch if you need to do it, because you have to create the shipper, the listing, the carrier, put them into something we call a network, check out with that person, and then finally get into that state where you can start testing things after the match. That's a lot of time to do it manually, but everything that we have happens to be in our test SDK, and everything's already there. So I create the shipper. I basically enroll that shipper into some specialized permissions so that they're able to access auto booking. The partnerships created, the matches are all made. And there's a couple of console logs that are there. And basically what we do is once you have the test script going, you just print out basically the user data. So I print out the email address, I print out the listing ID, and between those two things are just logged out. I can just log into the system myself and then basically start poking around at a place where we already have all the context set up. And so you don't have to do all that manual labor prior to going into testing the things that probably are more interesting to your QAs besides the happy path. All right, benefit number 2. So this one is more personal to me as the test architect for our company, because I think running test automation, your devs probably do it, some of your QAs or SDETs do it. But for me, who has to take care of all the governance and ensuring standards and best practices, this is where I really found the benefit of our test SDK. So like I said, I'm responsible for supporting all of our team's automation efforts. And I think a lot of that is trying to just limit the tooling that we have. Because like I said, as fun as it is to learn about Test Cafe and Nightwatch and Playwright and Puppeteer, I would rather not have to context switch on a daily basis. And so I think one of the things that the test SDK allows you to do is it helps you to basically limit your supported tooling, because it'll keep you sane, keeps maintenance reasonable. And I think as a further plus, it helps collaboration between teams, because like I'm here on this conference this week, I'm out of town for a week. They don't have to Slack me while I'm here. They can just ask someone else on another team. And so one of the things that we've done, which arguably this will be a little bit controversial, is we incentivize standardized test architecture by actually tightly coupling our frameworks to the test SDK. I think when people hear the words tightly coupled, especially in a distributed system, they're like, oh, that's bad. That's really bad. But I will argue that's actually beneficial for us to marry our test framework of choice to our test SDK. This helps us to standardize a lot of things. I'll show you some examples. So one example for us is creating what are called default fixtures for our end-to-end test framework of choice, which is Playwright. If you're not familiar with fixtures, basically Playwright spits up like a test instance that effectively like a single browser instance, but you can customize it to, for example, have like a default viewport, or you can have some secrets or some routing in place. And so at least for us, for this example, I'm going to talk a little bit about secrets and having some cookies preset. And so all of our tests at uShip, we basically run them inside a virtual private cloud, because we don't want the public internet to see uShip dev. And so basically, the part of what it takes to run things inside that virtual private cloud is to basically have basically some headers appended to all of our browsers such that it has access. And so basically every one of our repository micro front ends that needs to run test automation against our dev instance basically needs to have that header appended. And so you could append this in every single one of your test repos as a helper, or you append it individually to each test. But we actually just chose to install Playwright into our test SDK, and then set the headers here in one place. That way, instead of importing the base test instance from Playwright when you install it, you can just import this specific desktop test fixture instead. And then all of our tests will inherit the preset client ID and secret that's needed to access our lower environments. And so I think the other thing that's nice about this is, yeah, we roll our secrets on a regular cadence. You don't have to go update it everywhere. You can just update it in one place here in the test SDK. And then everyone inherits that new the new updated secrets as the package gets updated. And so other things that we've done is we've also been able to roll out test features to our organization through our test SDK. And so the last initiative that I've been working on this past year is actually rolling out test reporting. And so we've chosen to use Allure as our reporting framework. We basically have a web product, a mobile product, and then an API product. We wanted to basically start tracking, like, what is the efficacy of all of our tests? And so for the sake of just modular code and future-proofing, we basically just implemented an interface inside of our test SDK so that it doesn't matter what version of Allure we're using or which flavor of Allure we're using, it's all done basically in one place. And so in this example, basically, we have this interface that has label, add label, owner, and add owner. And you kind of wonder, like, why is there label, add label? Like, why is there label and add label? Well, it turns out Allure just chooses to implement differently in WebDriver IO and Playwright. And so we just put all the signatures into one interface such that it's just easier to grab from. And so what this means, though, is basically teams don't have to install Allure individually into their repos either. Again, they just install the test SDK, it has access to Allure, and they're able to start tagging the metadata appropriately. And the other thing that we've done is inside the test SDK down here is like our domain teams. So we have we just recently did a team swap. So I'm trying to, so we have actually 4 teams now. This is not necessarily up to date, but effectively we basically put all of our team names as enums. This way, if people are trying to tag their tests with metadata, they don't accidentally misspell a team name or something, and then that messes up the data inside the data lake. We're able to just store all the teams and bounded context or whatnot all here inside the test SDK. And as I mentioned, we just swapped teams. So next week when I get back, I just need to change the names of these teams, push out the newest version of the SDK, and then teams can just grab those new enums instead. All right, benefit 3. So lastly, I just want to talk about just a little bit about maintenance. So how do we update this test SDK? And I think the beauty of package distribution is it's actually really simple. Like I said, everything lives in a centralized package. And so when we make changes, we basically just put our test SDK under version control, and then the new versions basically get pushed out and doesn't break our consumers of the SDK. And we use something called semantic release to take care of this. Basically what this means is like teams can basically update at leisure, like short of like a major system-wide change. But as we push out new changes to our test SDK, it's not going to blow up any team's pipeline. So like, for example, maybe one team is on version 8 of the test SDK, and we've pushed out version 8.1. Teams don't immediately have to update to 8.1. They can update whenever they're ready to do so, or if they need to consume the new feature that's in 8.1. Otherwise, they can kind of sit still until it's actually needed. And so maybe for those of y'all who are less familiar with semantic, basically semantic automatically buckets your changes into 3 different categories based on whatever your git commit message is. So there's one called breaking change, and basically this means, hey, you need to refactor your code to be able to use this new version of the SDK. And that normally necessitates a major version bump, so it goes from like version 8 to version 9. A major change is probably some new feature, and so this goes from like 8 to 8.1. This can probably be auto-updated, or you can just let it sit there, probably doesn't hurt anyone. And same with the minor changes. It's normally bug fixes or other minor things. It probably goes from like an 8.1 to an 8.11 or something like that. And I do want to just call out, like, the nice thing about semantic is maybe for those of you who are familiar with like Renovate or Dependabot, some of these packages can be auto-updated depending on what your configurations are. Like if you have it set up such that, hey, all my CI/CD tests pass when I publish this new version of this SDK, it's automatically distributed. And so that helps the maintenance side a lot. All right, so just to recap so far, so why should you build a test software development kit? Kind of talked about basically the centralized core test helper methods as a factory. You can standardize your test architecture, or you can even roll out new things. And then this package distribution allows for easy updates. And so I'm going to transition a little bit about just some tips and tricks. So hopefully I convinced you of why it's worthwhile to build one of these things. So I'm going to give you a few tricks that we've learned along the way. Just to give you all an idea, when we first built this thing, it took us about 3 to 6 months to get like a version 1 out. I'll talk a little bit about like the versioning here shortly. But we're a relatively small org, so we basically just had one SDET working on this. So it took a little bit more time to build some of this stuff, but obviously, depending on our scale, might build faster. But tip number 1, I would say, is just start your test SDK just by exporting your existing helpers. If you already have test automation existing inside your org, it probably works, or hopefully it works, or your helpers at least work. And so you don't necessarily need to reinvent the wheel. I think if you have your helper function somewhere else, you can probably just copy paste them into a new package and then build the package and start from there. I think for us specifically, because we migrated from C#.NET to JavaScript, we've had to do some additional work to make all the conversions. And this is the only AI plug I will make inside this presentation, but ChatGPT does a great job of converting C# to JavaScript. Obviously, you do need to like finesse it a little bit, but it speeds it up a lot faster than you would think if you're trying to do like a modernization type thing. I think it's also helpful, like kind of talking about what the 3 to 6 month time period. Yeah, we basically have to figure out what's our MVP for our test SDK. Like, what does version 1 look like? What does the org actually need such that this thing is actually usable? And I think one of the talks yesterday I was like, yeah, one of the biggest mistakes that you can make is you build a thing, but then no one uses it. So we wanted to make sure whatever our V1 was, people will use it immediately so that we can start deprecating some of our old code. And so whatever that threshold is, it depends on your company, it depends on your teams. Whatever that core business logic is, once you figure out what that is and you've built it, I would cut version 1 as a release, have your team start consuming it, and then basically use semantic release to push out whatever new functionality you need afterwards. And so I think on the right, again, it's a little fuzzy, I apologize for that. But basically, this is the C# code that is basically our user creation factory. And then this is basically it rewritten in JavaScript. It's basically, we just moved the model out, but at the core, it's just the same. It's just a few different libraries. Tip number 2, I would just limit your SDK to whatever is reusable functionality. So especially in a distributed architecture, you're going to see like, hey, there's a lot of different things that gets built, a lot of new features that get built inside of separate projects. But I would only add things to your test SDK that are basically shared amongst multiple repos. I would just leave the one-off functionality. It's on the side. If you find that one-off functionality suddenly no longer becomes one-off functionality, then I would move it into your test SDK. And I think the reason for this is it just limits scope. And it gives you a gauge of what's actually like truly important in your product domains. Because yeah, you could put every single piece of functionality into your test SDK, but if you're trying to avoid that giant ball of mud, because it's possible for your test automation strategy to also become one giant ball of mud. And so distributed architecture, I would still try to leave your test concerns in as distributed as possible as well. And so I think generally speaking, like in terms of reusable functionality, I think users are the classic example of what contexts generally need to be shared across your domains. I think conversely, we have at uShip, like a specific service called Electronic Bill of Lading, or EBOL. Basically, for those of y'all who have probably received a package from FedEx or Amazon, it's basically the thing that you sign for. That's what the service is. But that only applies to a very certain subset of our listings. And so while that EBOL test data generation could live inside the test SDK, all our tests for it only live in one repo. And so we have chosen intentionally not to move it into the test SDK. And so again, it's up to you. Maybe if you think in terms of like the future, like, hey, we're going to have this thing in multiple places, you can move it in. But if not, you can leave it separate for now. And then if you do need to move in, it's relatively simple to copy paste. All right, tip 3. This one, I know everyone loves good documentation. And so having a good table of contents is really invaluable. I think especially like, I think generally in software, it's like kind of like a living ship of Theseus. You take one plank out, put a new plank in, new engineer leaves, new engineer comes on. But basically having good documentation, especially how like your test automation architecture works, like your test SDK, like if they can just read this, they can self-service and figure out, yeah, this is how I write my test automation, or how do I use this thing to speed up my test automation. And so what we've done there on the right is, yeah, this is just how you configure our test SDK. There's some sample implementation. One of the things that we do at uShip is you can actually run our tests in any environment. So we have a dev environment where it's kind of like the dev playground, our QA environment where all the test automation actually runs, sandbox for our integrators, and then production is prod. But one of the things about our test SDK is we built our test automation strategy in such a way where you could actually run our tests in any environment. You just have to point the SDK to which environment you want to run things in. But there's just some sample setup. It tells you what properties there are, what the data types are, so that everything is set up for people to run with. And then maybe you're like me, you really hate writing documentation, even though you know it's valuable. There's some plugins that at least will give you a shell or do some of the automated writing for you. But it still obviously needs to be updated and kept up to date for it to be useful. All right, tip 4, I would strongly recommend typing your test SDK and then basically building it in a strongly typed language. I'm generally more of a fan of actually just procedural code, but I do acknowledge that for a test SDK or something that's going to be used by multiple teams, and you want it to be as bug-free as possible, since having the strongly typed data structures at least minimizes your defects. And so I would highly recommend picking something like Java or C# or TypeScript instead of like vanilla JavaScript to write it, just so that, yeah, it'll just minimize a few defects here and there. I think also going back to like the developers going in and out kind of scenario, maybe some of the documentation that you have existing for some of your APIs or how your system works isn't super well documented. Maybe like, for a specific function, like the signature is not clear. Like, is it supposed to be a string? Is it supposed to be an int? Is it supposed to be some other data type? Just having it in the doc, having it strongly typed will automatically error things really quickly. And then most of y'all probably code in an IDE, or maybe you're using Copilot or something else along the lines that does autocomplete. The autocomplete will help speed things up, especially if things are already strongly typed. Tip 5, test your test SDK. Basically treat it like it's production code. I know sometimes automation code gets the short end of the stick, but because so many people are going to be consuming this thing, especially in the distributed architecture, like I said, we have a ton of repos. Basically, we want to be able to test our test SDK before we roll it out to our engineers. So at the minimum, we basically do unit tests, integration tests, end-to-end tests as necessary. And even from like the process side of things, we actually have our SDETs QA each other's changes to the test SDK. So they will package up the SDK locally, download it, install it inside of a new repo or a repo they're currently using, utilize the functionality in there to make sure it works the way we expect it. And that we get that approval and QA approval and sign off before we actually release it to our engineers. All right, and then last tip is just kind of having a process to address, feature requests or bugs. I think this is just general project management, but at least for me, I know I have a ton of people who just Slack me directly. It's like, hey, like, have you noticed this bug? Or hey, have you we would really like you to add this thing to the SDK so it helps speed us up. I'm like, that's great. I also have about 20 other things I need to do, so let's put it into a backlog. I'll get it prioritized. Maybe have another engineer work on it if I don't work on it. That way, you just have things tracked and you know what needs to be built. If you don't use Jira or don't have a Jira project dedicated to your QA or SDET team, but there's also, because ours is in GitHub, you have like GitHub issue tracker or whatever else, just carve out tickets that way. Okay, so this sounds great. Everything's awesome, right? Like, we're writing more tests than ever before. Tests are writing faster. Things are less flaky. Everything seems great. But I would like to wrap up just with saying, here's what we've learned along the way. We've done a lot of amazing things in the distributed architecture side. Things are a lot better than it used to be. But I would be remiss to not at least address some of the pitfalls that we've run into. So one is just maintenance. I think this is not unique to a test SDK. I think just generally speaking, maintenance is hard in general. But I think, as your software landscape evolves, teams make updates to features. Well, let's say, like, again, going back to that user example, like someone still needs to come in and update the test SDK. Like, I think it still slips teams' minds way more than you think. Like, oh, I make a change here, I might update the test automation here, but oh, I forgot to update the SDK and I broke some other people's stuff. I think part of that goes hand in hand with like ownership. Like until last week, the SDK did not have a formal owner in our company. Like our owner was SDET, but SDET is not a team at our company. It's just like our QA group. And they're also on delivery teams themselves, and so it's kind of hard to like prioritize and find time for the maintenance. And so, yeah, even if it's not like feature related updates, like someone's got to do like security package updates. Someone's got to make sure things are still deploying, update node version, that kind of stuff. So we do use code owners to say like, hey, at least SDET like owns the test SDK, but if you can formally give it to like a platform team or something, that would be ideal. Data cleanup is hard. So hopefully your company, if you're doing test automation, already has some kind of data cleanup strategy. I will say our company does not. And so we're generating a ton of test data, like hundreds, thousands of rows of test data a day. And it's all going into our database. And that's fine because they're all isolated. We'll never see them again. But at a certain point, over 20 years, that's a lot of test data, and you got to clean it up at some point. And so I would just make sure, talk to your DBA team, make sure you have a strategy for how to clean up your test data. And then lastly is just adoption of the test SDK. So like I mentioned a little bit before, one of the pros is it's great that your team can be on V8 of the test SDK. You can roll out 8.1 or 8.2, and teams don't have to update immediately. That's true to an extent. At a certain point, you need to do some cutoffs because, hey, I don't want to have to maintain Node 14 for you for this test SDK because Node 14 was end of life a couple of years back. And so right now, our test SDK currently is on Node 20. And so there's a lot of new features, but some teams can't use those features basically unless they update to the latest. And if your repo is still stuck on Node 14, you have to do the maintenance to get whatever the consuming repo is up to Node 20. And then you have to refactor all your changes for the test SDK to also go from there. So for example, one of our teams, because their repo hygiene was very poor, they were on V4 of the test SDK, and then they had to bump all the way up to V10. And so while the test SDK changes are probably less radical than other major package bumps that you have to do, that's not an insignificant amount of work to do that either. I mentioned a little bit before, there's things like Renovate and Dependabot that can automatically do this for you. But someone at the end of the day still has to be responsible for merging or keeping an eye on how up to date that maintenance actually is. All right, so final note. So this is the last slide. Just as a wrap up, we kind of talked about what is a test software development kit, what the benefits are, and some tips on how to build one and what are the challenges. And so I think from my personal experience, wow, it's easy to say this is the best thing since sliced bread, because as the primary person and test architect, yeah, I can now build this thing. My teams are free to write their own test automation. They're empowered to basically increase quality across our org. But I will say though, maybe some of y'all are not necessarily there on your CI/CD journey. And so I will say the test SDK is also not a cure-all. Yeah, maybe you're not that far yet. Maybe you're just starting test automation. Maybe you're just starting CI. But I think that's great. I would just get test automation written first, get it working. You can wet code's not great, but it's better than having no test automation code at all. Or maybe your APIs aren't quite ready to create this much test data, or maybe there's some problems that you need to address there first. Go fix that first. Make your system testable before you go dive the deep end in terms of building out something more formalized for your test automation strategy. Because at the end of the day, I kind of started by saying the test SDK is just a toolbox. That's really what it is. It's just a tool to help you along in your journey. It'll make your life easier, but it still needs to be used in the right way. And I think your mileage will vary based on your company culture, adoption, all those different kinds of things. But I think if you can get buy-in from your leadership or your teams, I think it will help speed up a lot of development inside a distributed system. So that's my talk. Questions?
Have a lot of projects, and we also that but with the NPM package. So other projects can import with the NPM dependency and remove our library. The question, how we do that, since you also as I see use the JavaScript ecosystem, and maybe this is another way better to import the
Yeah, so we have our company has an internal NPM repository. And so we basically, when we publish all of our internal packages to that repository, and then based on NPM access, our repos are able to pull it from there. So we also have Yarn in one of our other repositories, and basically we dual publish. But for the most part, it's just NPM install, and as long as the repo configurations are set up, it's able to pull from there.
And do you use Docker?
We do not use Docker.
Because somehow not everyone in the team has the JavaScript infrastructure.
Mm-hmm.
Maybe they can do the program with some additional programs.
Yeah, I think that at that point, I think that's a conversation for your platform team or your DevOps team, because we collaborate a lot with our DevOps team because we know that we primarily take care of the test automation. A lot of our SDETs are capable of working in some of our CI portions of the infrastructure, but like there's certain permissions types things that we pass it off to other people.
You mentioned initially you had a framework, multiple frameworks for the API, UI. Can you talk about sort of your SDK use for both API services and then
Okay, yeah. So the question was, is the internal SDK or the test SDK that we built both for UI and API testing? And the answer is yes, because so like for our API tests, like generally we just need like a user and a listing. And so that's an API call in and of itself. And we basically just call, like in our API frameworks, we basically just call it as setup to create our user and our listing. It doesn't necessarily mean like, even though like Playwright is bound to our test SDK, we're not using Playwright in our API test framework. It just has access to the API calls so that we don't have to rewrite the user helper inside of our API or inside of our microservices. And then the UI, it does have access to Playwright, and it installs Playwright from the SDK in that case. So in a certain sense, like for our API test framework, like it's got a little bit of bloat, quote unquote, because like you don't need access to Playwright inside the microservice, but it just simplified things for us overall, because if it's installed as a dev dependency for us, it's not going to make it to the production application anyways in terms of like package size. So we decided it's okay.
so can you go through how did you guys evaluate creating your own in-house SDK versus standardizing on, say, an off-the-shelf already available IDE, test IDE, such as there's tons out there, Smart Bears, Test Complete, things like that. So what was the decision making? And instead of using an off-the-shelf and creating an API within that does the things you want to do versus creating an in-house SDK and having a team dedicated to maintaining that.
Yeah. So the question is, why build our own SDK instead of taking an off-the-shelf solution effectively? And honestly, that's just how we do things at uShip. I think I would say like a couple of years back, especially, we didn't really do like a ton of the cost benefit analysis. Just like, just go. Part of it's just startup culture, which is just fun. I think I think in hindsight, as you asked this question, I think I would still have built it from scratch because it allowed so much customizability. Because like off the shelf, like yeah, you're not going to be able to like bind a lure or Playwright to the test SDK. Like you can, maybe you can, I don't necessarily know. But I think we enjoyed the flexibility of like, yeah, being nimble and being agile. Like whatever the needs were, we can just throw it into our custom SDK. We also helped that we had the buy-in from our leadership, our engineering leadership team, CTO, to like, hey, we know that this is an investment in the long term, especially as we break out into more and more microservices or micro front ends. So there was never like a doubt that like, hey, you can't take the time to do the maintenance of this thing or whatnot. Just build what you think will help us most in the long term.
I run into it is like abstraction and test code and instruction and test code are very different things. And I see that's like not really being sure how to treat abstraction and test code. So I generally agree with you unless something's already like the Paragraph does like adding like one-off methods to the SDK. Or on the flip side, you know, there will be a very sort of method and they'll it.
Yeah. So I think the question is, there's oftentimes like multiple people contributing to an SDK, and so it's hard to, sometimes one-off methods do get added to the SDK. Is that like crux of the question? So I think what we've done is, one, going back to like the table of contents, we make sure it's very up to date such that it's easy to control. Before anything gets added, like they just control search, like look and see if it already exists in the documentation. Then to the code owners aspect, because SDET is our code owner for the internal SDK, we have the ability to reject any PR that like anybody who makes a pull request to add a new feature to the SDK, we have the right to reject it. So like, oh, this is only a one-off method. Like, sorry, we're just not going to let you add it. So that's more like the architecture and the governance side of things. But we are very strict about like, hey, we know that this thing's going to get bigger and bigger. Like we want to be able to maintain it. And so like, obviously, like if there's like good use case for why it's being added or like preemptively added, like sure. But those are conversations, open conversations and dialogues that we have with the people who are trying to add stuff.
Yeah, so about how you addressed some of them, especially when it comes to like maintaining the feature versus
Yeah. So the question is, like, how do we find time for basically maintenance while balancing like your normal like testing duties for your delivery teams? And I will say it's hard. But so at our org, so I'm not on a specific delivery team, so I actually have a lot of the freedom to be able to go take care of the maintenance stuff. That's not necessarily a good thing either, though, because that puts you into bus factor territory where you're the only person who knows how to do stuff. That's not good either. But what we do is, at least how our QA SDET org is organized, basically everything we do is basically encapsulated inside Jira tickets. So like, hey, let's say like test SDK maintenance or whatever. Basically, we will put it into a team's backlog and tell them, hey, for next like sorry, let me back up a little bit. We have a mutual understanding with management and leadership that for our SDETs, 20% of their capacity each sprint has to be allocated to just automation work and maintenance. So it's already a non-negotiable. So it's like, hey, like I know you're trying to pump out more features or there's more other tickets pressing, but we have just a standing rule that like, hey, SDET has to basically at least pull in one ticket a sprint to basically maintain our test automation or SDK or whatever, what have you. So for us, it's not necessarily like maybe it gets delayed a sprint or two, but there's always space carved out. So maybe like on a day-to-day, like our SDETs and QA, like they're doing the testing for things or they're writing automation for their current deliverables, but the ticket exists there and it's prioritized and it's accounted for the velocity.
I'm trying to visualize this from a developer point of view. So if you're a mobile developer, they'll have their mobile code, they'll bring down the SDK. Are you finding that they're going to start writing more tests because you've got the SDK available? And then maybe your API developers writing tests and integration and unit. I mean, it sounds like this SDK is maybe enabling them to add more tests, which is the opposite problem I have. Our developers are not able, so for their mainly. And so I mean, this looks promising. I mean, that's what you're seeing. Like, or are you writing tests? You have a QA staff now that's doing things, or is that kind of gone by the wayside?
Yeah, so the question is like, does having a test SDK enable developers basically start writing more tests? And I think the answer is yes. Yes, overall. I think our developers are writing more tests because of the test SDK, because there's a lot, we just put so many bells and whistles on it that like, hey, it's easier to use. Again, a lot of it, I think, for at least for our company, we didn't have problems with developers writing tests to begin with. This is more so just to like, hey, stop copy pasting like helpers everywhere. So they appreciate like it's enjoyable to use because the maintenance is better. That said, at least for our organization overall, like our QAs and SDETs, they handle most of the test automation. Obviously, our developers are capable of doing it and they're willing to do it. But we've kind of carved out the space where, yeah, our SDETs primarily are the ones who are writing the automation, or at least they're specking out what needs to be automated if like a developer needs to hop in. So I think we have very like clear like definition of roles, I guess. And so I'm not saying I would say our devs aren't unwilling to test. I think it's more so our culture's such that they'll write it regardless.
Let's say you've got a new field on the front end, that you also need a new field in the database, and you're going to need the API to handle the new field. So at that point, you know, in the SDK, you've got your developers writing those tests, or are you writing all those? Like we're testing, hey, we're adding it and we're testing it. So that who's doing the majority of testing now? But somebody's gotta add a new field and make sure it fills up properly and has proper validation. You know what I'm saying?
Yep.
That's a good example.
Yeah. So I think, so the addendum to this question is basically like, for example, like going back to like adding a new field somewhere and adding a new field to a database, like who makes the changes to both the feature code as well as the SDK? And the answer to that for us is the developers. Like the developers will implement, the new functionality. They'll go into the SDK and update the SDK. The QAs will still test the SDK and make sure that it works appropriately, or they'll sign off on the changes inside the test SDK. Our SDETs are capable of making the changes to the test SDK, but because all that's going to get released together, it makes sense to keep it all under one ticket.
That's testing easier and
So the question is, like, would the test SDK make regressions and smoke testing easier over time? And I think the answer is yes. Like for us, one, this enabled full CI/CD across all of our distributed systems. So we already have a lot of like coverage as a result just from our automated tests. I think earlier I showed the example of like being able to generate the test data on the fly for our manual QA. Like, yeah, it's like I need like 10 users. Like I just hit the script 10 times. I already have 10 users basically in a state and context that's ready to be like go start exploring edge cases or exploratory testing. And so, because again, like I think the test data setup is often the most expensive portion of the, at least for us in our experience, like most expensive portion of QA. And so I think overall, like, yeah, our SDK has enabled at least a lot of that.